Folks, today I have a lesson for you on determining using calorimetry the delta H for our reaction. So first I will be writing down a question and then we'll be going through that question together. In this question, it says a chemist, a pen right here, and it says a chemist wants to determine the enthalpy of neutralization, the enthalpy of neutralization. Now, since they're talking about enthalpy of neutralization, we know it's going to be an acid-base reaction because an acid neutralizes the base, or the base neutralizes an acid. So neutralization reaction for the following reaction, So the reaction at this point will be given in the question. It says HCl with a bracket AQ representing it's an acid dissolved in water, and then it's reacting with NaOH, which is our base, with AQ again because it's dissolved in water, and it is going to be forming a salt and water as an acid-base reaction usually does. So in this case, the salt is going to be the NaCl, and this case this is in water again because this reaction is taking place in water, plus H2O, which is water, and this is going to be in the liquid form. What we are trying to do is we're trying to find a delta H for this reaction is equal to how much, right? So that is what we're going to try to find. So next, it keeps on going. The question continues and says the chemist uses coffee cup calorimeter, to neutralize completely 61.1 milliliters of 0.543 moles per liter. Right. So based on the units, you can predict and guess what this is, what quantity they are trying to refer to. When it says 61.1 ml, ml or milliliters is a unit for volume, amount of space a substance is taking. So in this case, the volume is 61.1 ml. And then it says of 0.543 moles per liter. Moles per liter is a unit for concentration. So in other words, they're saying the volume of the substance is 61.1 ml and the concentration is 543 moles per liter. And then it says HCl. So that means this is the information about HCl. And this is reacting with 42.6 ml. Again, it says ml, which means it is a volume of NaOH. Okay, and so that is the information given there. The initial temperature, it continues on, the initial temperature of both solutions is 17.80 degrees Celsius, which is representing the temperature or the starting temperature of both solutions. This is the starting temperature. And then this says after neutralization, so after the reaction has taken place, the highest recorded temperature is 21.60 Celsius. The question is asking us to calculate the enthalpy of neutralization. So calculate the enthalpy of neutralization in kilojoules per mole, so in units of kilojoules per mole of HCl. So you're going to be figuring out the delta H for this for in terms of HCl. Also, additional information that they gave us is we can assume certain things to make our work a little bit simpler. Assume that the density of both solutions is 1.00 grams per mole, grams per milliliter, which makes a conversion easy because if the density is 1.00 grams per milliliter, that means if I have 1 gram, I can substitute that for 1 milliliter, or if I have 1 milliliter, I can substitute that for 1 gram of the substance. And that will help us to convert volume into mass and mass into volume. So for that conversion, we always need the density value. Also assume, so it says also assume that the specific heat capacity, of both solutions, is the same as the specific heat capacity of water. That means we can use C for all substances as 4.18 or 4.184 joules per gram degrees Celsius. And the reason for that is because most of these solutions and most of these reactions are taking place in water, and the concentration of HCl and NaOH is very, very small. Now, if they were highly concentrated solutions, then we could not assume the density of all solutions as 1.00 grams per milliliter. Right, so now we have the question set up. We need to come up with a plan as to how we are going to solve this question. So in this reaction, if we see the initial temperature is 17.80 degrees Celsius and the final temperature is 21.60 degrees Celsius. Right away, we can tell this is an exothermic reaction. The reason for that is the temperature of the solution, or the temperature of the calorimeter, has gone up. Since the temperature is going up, that means energy was released from the solution, from the reaction, and therefore this is an exothermic reaction. All right, so now to solve this question, we need to find out the amount of heat energy released in the solution. To figure this, we need to find our Q for this reaction. So what happened is energy for Q. And for figuring out Q, we need the mass, and we need the mass, first of all. Which mass do we need? Do we need the mass of HCl, the mass of NaOH? Well, the temperature of the entire solution will increase. And therefore, we need the total mass. Not the mass of HCl, not the mass of NaOH, but the combined total mass. And so we need the total mass to figure out the Q for the reaction. So we need the total mass. We need to calculate that. And we need the specific heat capacity of this solution. Now, since they said that you can use the same as the specific heat capacity of water, we can use C of H2O. And again, this is a lowercase c for water. We can use that, which is 4.184 or 4.18, as some people like to use, for the specific heat capacity of water. And then we need to know the change in temperature of the solution. Change in temperature would be final temperature minus the initial temperature. That will tell us the change in temperature of the surrounding or the solution. Once we have these values, once we have figured out the Q, this is the total amount of energy that is released in this reaction. We will have to then figure out how much energy was released per mole of HCl. And for that, we will have to do an additional calculation to figure out the amount of energy released per mole of HCl by taking the Q and dividing it by the number of moles of HCl. So that is the delta H is equal to negative Q over N. The reason for the negative in that equation, so I'll write down the equation here. So once we have done this, we will do this. The second equation, this is delta H is equal to negative Q of the reaction over N. The reason for the negative sign is that the system, so delta H is the energy of the system. So this is the system here. System is the chemicals in the solution, and what is happening to these chemicals in the solution? They are releasing energy. So the energy of the system is decreasing. Now, when we talk about the Q of the reaction, this is the surrounding. And the temperature of the surrounding, or the energy of the surrounding, or the heat of the surrounding is increasing. So the system is decreasing, surrounding is increasing, and therefore they are opposites. So Q, or energy of the system, is opposite to the energy of the surrounding in terms of the sign, because one is losing, one is gaining, but the magnitude, the amount is the same. So the amount of heat is the same, but the signs are different. But in this case, they want it per mole, and that's why we have to divide this value by the number of moles of HCl we used in this reaction. So I hope that was clear. So let's then try to solve this question. So first, we will have to solve for Q, and then we can use that to find the delta H. Okay, so let's go for it. So let's find Q of this reaction, which is equal to the masses. Now, mass are given, we don't have the grams of HCl or the NaOH, but we have the density and we have the volume. The total volume that we have in this reaction is 61.1 plus 42.6 milliliters, which gives us 103.7. 103.7 milliliters. And since we have the density as 1 gram per milliliter, it will be the same as 103.7 grams. That is the total mass that we have in this reaction. The second piece of information we need is the specific heat capacity of water, which is 4.18 joules per gram degrees Celsius. And the last piece of information we need is the change in temperature, which is going to be 21.6 minus 17.8. And that gives us about 3.80 degrees Celsius change in temperature. Again, because it's a subtraction, we are using decimal places as significant figures to determine how many digits to keep in the answer. So since it is a subtraction, we are using decimal places, 2 decimal places in the question's value. Therefore, there should be 2 decimal places in the answer. Now, I haven't shown the separate calculation for mass, and you should really write down M total and then calculate the M total and then the delta T and then write down the delta T, calculation, before you write this final step. But I'm able to do this because I'm actually orally explaining this information to you. So that is why I did not spend time to rewrite that information. But for a question that you're solving, you should, for a question that you're solving, and not orally, but in written and communicating with somebody else, you should put down how 103.7 grams was obtained and how 3.80 degrees Celsius was obtained. Now, once we have all of these values, we can solve for Q by taking 103.7 grams times 4.18 times 3.80. And that gives me a value of 1647.1 1708. And that's the numbers. I'm putting all the numbers that I got on the calculator, and I got this will be in joules. Okay, I'm not rounding off the values right now because this is not the final answer. Rounding is only the step that you do for the final answer. Any intermediate calculation should not be rounded off and should be kept as exact as possible. Okay, so once we have the Q value, which is 1647.1708 joules of energy, we need to figure out the delta H. Now, for delta H, they have asked us the units kilojoules per mole. So we need to convert this energy into kilojoules. So this is going to be equal to 1.64711708 kilojoules. Just dividing by 1,000, right? So we took 1647 divided by 1,000. We got 1.64711708 kilojoules of energy that was released in this reaction. Now, the first part is complete. We have found the Q for the reaction. Now let's look at this. Let's look at the second part. In the second part, we are looking for the delta H value. Right? Delta H is equal to how much? To solve for delta H, we need two pieces of information: the Q, which we have, and the N, which is the moles of HCl. Now, to find the moles of HCl, what we can do is we know moles of HCl is equal to concentration times volume, C times V. C, again, this is coming from grade 11. C is 0.543 moles per liter. They gave us that information, times 61.1 ml. This is equal to, so 0.543 times, before we multiply, if you see the volume is in milliliters, we need to convert that into liters, which is equal to 0.543 moles per liter times 0.0611 liters. Because if you see the units for the concentration, they are in moles per liter. Okay, so let's continue the calculation. So 0.543 times 0.0611. And that gives us a value of 0.0331773 moles. So now we have the amount of moles and we have the amount of heat that was released in this reaction that we recorded from the calorimeter. Using these two, we can figure out the delta H for this reaction, or equation if you want, which is equal to negative Q over N. So, which is, again, plugging in the values, negative of 1.64711708 kilojoules over 0.0331773 moles, and that will give us our value of, let's calculate this value over, okay, that's the 1.64711708 divided by 0.0331773, and we get 49, so negative 49.64752,406 kilojoules per mole. And rounding off to proper number of significant digits, the Q value was 3 significant figures. The volume was also 3 significant figures. The answer should be 3. So in other words, this should be a negative 49.6 kilojoules per mole. Right. So we have found the delta H for the reaction that was given to us. So we're going to write it down. Finally, we have an equation which is HCl AQ plus NaOH AQ reacted to produce NaCl AQ dissolved in water plus H2O, which is a liquid, with the delta H value is equal to negative 49.6 kilojoules, and that negative does make sense because the system lost energy in this reaction, or the reactants had more energy and they lost it, and that's why the temperature of the solution increased, or the surrounding had increased. The other way to write this equation as energy as part of the equation, and since this is an exothermic reaction, the energy will be written on the right hand side. So NaOH, AQ will form NaCl, AQ plus H2O liquid, plus we will have 49.6 kilojoules of energy that is going to be released in this reaction. This is kilojoules per mole of HCl. We are referring to HCl in this case, and since everything is in the ratio of 1:1:1:1, we can also write it as plus 49.6 kilojoules of energy.